Welcome back to our channel. Today, we're diving into the fascinating world of statistics and its various applications across different fields. Whether it's predicting weather, analyzing the stock market, or understanding the stars, statistics is everywhere. Let's explore how different disciplines utilize this powerful tool. Statistics is the mathematical science involving the collection, analysis, and interpretation of data. A number of specialties have evolved to apply statistical methods to various disciplines. Certain topics have statistical in their name, but relate to manipulations of probability distributions rather than to statistical analysis. Exploring the power of statistics across diverse fields, from finance to astronomy and from biology to physics. Actuarial science applies mathematical and statistical techniques to assess and manage risk in industries like insurance, finance, and pensions. Actuaries analyze data related to life expectancy, accident rates, and economic trends to determine insurance premiums, pension contributions, and financial reserves. For example, an actuary might estimate the likelihood of natural disasters, helping insurance companies price policies accurately and maintain financial stability in the face of unpredictable events. Actuarial science also plays a crucial role in developing strategies for investment portfolios, balancing risk and return. Astrostatistics combines statistical analysis with astronomical data to explore the universe. It is vital in handling the massive datasets generated by telescopes and space missions, such as those used in the search for exoplanets or the study of galaxy formations. For example, astrostatisticians use techniques like Bayesian inference to estimate the probability of a star hosting a habitable planet. In addition, astrostatistics aids in analyzing cosmic background radiation, helping scientists understand the early universe and the fundamental forces that shaped it. Biostatistics applies statistical methods to biological and medical research, playing a key role in public health, epidemiology, and clinical trials. Biostatisticians design experiments, analyze biological data, and interpret results, ensuring that medical research is rigorous and reliable. For example, in drug development, biostatisticians assess the effectiveness and safety of new treatments by analyzing patient outcomes in clinical trials. Biostatistics also helps in monitoring disease outbreaks, modeling the spread of infectious diseases, and evaluating public health interventions. Business analytics involves using statistical methods and data analysis to drive decision-making in businesses. It helps companies gain insights from big data, optimize operations, and identify new opportunities. For instance, by analyzing sales data, a company can predict future trends, tailor marketing strategies, and improve customer segmentation. Business analytics also plays a role in supply chain management, where statistical models can forecast demand, reduce inventory costs, and improve delivery times, thereby enhancing overall efficiency and profitability. Econometrics is the application of mathematical and statistical methods to chemical data, used primarily in analytical chemistry. It helps in interpreting complex chemical data, optimizing experimental procedures, and improving the accuracy of chemical measurements. For example, chemometric techniques are used in spectroscopy to analyze the composition of substances, such as determining the concentration of different chemicals in a sample. In the pharmaceutical industry, chemometrics assists in quality control and the development of new drugs by analyzing the relationships between chemical properties and biological effects. Demography. Demography is the statistical study of populations focusing on aspects such as birth rates, death rates, migration, and aging. It provides valuable insights into population dynamics and helps in planning for future societal needs. For example, demographers use statistical models to project population growth, which informs government policies on healthcare, education, and housing. Demographic data also plays a crucial role in understanding social issues, such as the impact of aging populations on pension systems and the workforce, or the effects of migration on urban development. Econometrics. Econometrics applies statistical methods to economic data, allowing economists to test hypotheses, estimate relationships, and forecast future trends. It bridges the gap between economic theory and real-world data by providing tools to analyze and quantify economic phenomena. For example, Econometric models are used to study the impact of fiscal policies on economic growth, the relationship between inflation and unemployment, or the effects of trade policies on international markets. Econometrics also helps in evaluating the effectiveness of government programs and policy interventions. Environmental statistics. Environmental statistics involves applying statistical techniques to environmental data to understand and address ecological issues. It plays a critical role in monitoring and modeling environmental changes, such as climate change, air and water pollution, and biodiversity loss. For instance, environmental statisticians analyze temperature and precipitation data to study global warming trends and their potential impacts on ecosystems and human societies. In conservation, statistical models help in assessing the health of endangered species populations and developing strategies for their protection. Epidemiology is the study of the distribution and determinants of health-related events in populations, using statistical methods to identify risk factors and inform public health interventions. It is essential in understanding the spread of diseases, evaluating the effectiveness of vaccines, and controlling outbreaks. For example, epidemiologists analyze data from disease outbreaks, such as COVID-19, to determine transmission rates, identify vulnerable populations, and guide vaccination strategies. Epidemiology also contributes to chronic disease research, such as studying the factors contributing to heart disease or cancer and developing prevention strategies. Forensic statistics applies statistical analysis to evidence in legal contexts, such as DNA profiling, fingerprint analysis, and accident reconstruction. It helps ensure that scientific evidence presented in court is robust, reliable, and free from bias. For instance, forensic statisticians calculate the probability of a DNA match between a suspect and evidence found at a crime scene, providing critical information for legal proceedings. Additionally, forensic statistics is used in analyzing patterns in digital evidence, such as identifying anomalies in financial transactions that may indicate fraud. Spatial statistics deals with the analysis of data that has a geographical or spatial component, used in fields such as geography, environmental science, and epidemiology. It helps in understanding spatial patterns, relationships, and processes, such as the spread of diseases or the distribution of natural resources. For example, spatial statistics are used to model the distribution of pollution levels across a city, helping policymakers identify areas in need of intervention. In public health, spatial analysis can reveal hotspots of disease outbreaks, guiding targeted responses and resource allocation. Geostatistics applies statistical methods to spatial data in geology, meteorology, and other earth sciences. It is used to model and predict the distribution of natural resources such as oil, minerals, and groundwater. For example, geostatistical techniques help in creating maps of ore deposits based on sample data from drilling sites, optimizing exploration and extraction processes. In meteorology, geostatistics is used to interpolate and predict weather patterns, contributing to more accurate climate models and forecasts. Jurimetrics involves the application of statistical and probabilistic methods to legal issues, such as analyzing jury selection, predicting case outcomes, and assessing the reliability of evidence. It provides a scientific basis for decision-making in the legal system. For example, jurimetrics can be used to evaluate the fairness of jury selection processes by analyzing demographic patterns. Additionally, statistical models can help lawyers assess the likelihood of winning a case based on past verdicts and similar legal precedents, aiding in case strategy and settlement negotiations. Machine learning is a branch of artificial intelligence that uses statistical algorithms to enable computers to learn from data and make predictions or decisions. It is widely used in applications such as image recognition, natural language processing, and predictive analytics. For instance, machine learning algorithms power recommendation systems like those used by Amazon and Netflix, which analyze user behavior to suggest products or movies. In healthcare, machine learning models can predict patient outcomes based on medical records, helping doctors make more informed treatment decisions. Operations research applies mathematical and statistical techniques to optimize decision-making in complex systems, such as manufacturing, logistics, and supply chain management. It focuses on improving efficiency, reducing costs, and enhancing performance. For example, operations research is used in airline scheduling to minimize delays and maximize resource utilization, or in inventory management to ensure products are available when needed, while minimizing storage costs. Operations research also plays a role in military planning, where it helps in strategic decision-making and resource allocation. Population ecology uses statistical models to study the dynamics of species populations and their interactions with the environment. It helps ecologists understand factors that influence population growth, decline, and distribution. For example, population ecologists might use statistical models to predict the impact of habitat loss on endangered species, informing conservation efforts. In fisheries management, population ecology is used to estimate fish stocks and set sustainable catch limits, ensuring the long-term health of marine ecosystems. Psychometrics involves the measurement of mental abilities, attitudes, and personality traits using statistical methods. It is widely used in educational testing, psychological assessments, and employment screening. For instance, psychometric tests like IQ tests, personality inventories, and aptitude assessments are designed to evaluate cognitive abilities, emotional intelligence, and job suitability. Psychometric data is also used in research to explore the relationships between different psychological traits and behaviors, contributing to the development of theories in psychology. Quality control uses statistical methods to monitor and maintain the quality of products and processes in manufacturing and production. It involves sampling, testing, and analyzing data to detect and correct defects, ensuring that products meet specified standards. For example, in the automotive industry, quality control techniques like Six Sigma are used to minimize defects in car manufacturing, leading to higher reliability and customer satisfaction. In food production, statistical process control charts help in monitoring the consistency of product quality, such as ensuring that packaged foods meet safety and nutritional standards. Quantitative psychology applies statistical methods to study psychological processes and behaviors, often involving the analysis of data from experiments, surveys, and observational studies. It is used to develop and validate psychological theories, as well as to design effective interventions. For instance, quantitative psychologists might use factor analysis to identify underlying dimensions of personality traits, or regression models to explore the relationship between stress and mental health. In clinical psychology, quantitative methods are used to assess the effectiveness of different therapeutic approaches, guiding treatment decisions. Reliability engineering focuses on ensuring that systems and components perform their intended functions under specified conditions over time. It involves the use of statistical models to predict failure rates, design for reliability, and optimize maintenance schedules. For example, reliability engineers in the aerospace industry use statistical methods to assess the likelihood of component failures in aircraft, ensuring safety and reliability. In electronics manufacturing, reliability engineering helps in designing products that are resistant to wear and tear, reducing warranty claims and enhancing customer satisfaction. Social statistics involves the application of statistical methods to study social phenomena, such as crime rates, education, and public opinion. It helps researchers understand societal trends, inform policy decisions, and evaluate the impact of social programs. For example, social statisticians analyze survey data to study voting behavior, providing insights into political trends and election outcomes. In public health, social statistics are used to assess the effectiveness of interventions aimed at reducing health disparities, such as programs targeting obesity or smoking cessation. Statistical finance applies statistical techniques to model financial markets, assess risk, and develop investment strategies. It involves analyzing historical data to identify patterns, forecast trends, and optimize portfolio management. For instance, financial analysts use statistical models to estimate the volatility of stock prices, helping investors make informed decisions. In risk management, statistical finance is used to assess the likelihood of adverse events, such as market crashes, and to develop strategies for mitigating potential losses. Statistical mechanics uses probability theory and statistical methods to study the behavior of systems with many particles, such as gases or solids. It provides a molecular-level understanding of thermodynamic properties, such as temperature, pressure, and entropy. For example, statistical mechanics helps explain how the microscopic interactions between molecules lead to macroscopic phenomena, such as phase transitions like melting or boiling. In materials science, statistical mechanics is used to model the properties of complex materials, such as superconductors or polymers, guiding the development of new technologies. Statistical physics applies statistical methods to solve physical problems, particularly those involving large numbers of particles or complex systems. It is used to study phenomena such as phase transitions, critical phenomena, and the behavior of disordered systems. For example, statistical physics helps in understanding how magnetic properties change in materials as they approach a critical temperature, known as the Curie point. This field also plays a role in understanding the behavior of fluids, plasmas, and other complex systems, contributing to advances in fields like condensed matter physics and cosmology. Statistical signal processing involves analyzing and interpreting signals, such as audio, video, or sensor data, using statistical techniques. It is widely used in communications, control systems, and biomedical engineering. For example, in telecommunications, statistical signal processing is used to filter noise from signals, improving the clarity and reliability of data transmission. In medical imaging, statistical techniques are applied to enhance the quality of images, such as in MRI or CT scans, aiding in the accurate diagnosis of diseases. Statistical thermodynamics applies statistical methods to study the microscopic behavior of systems in thermodynamics, bridging the gap between macroscopic observations and molecular-level interactions. It provides insights into the fundamental principles governing energy transfer, chemical reactions, and phase changes. For example, statistical thermodynamics helps in understanding the distribution of energy among molecules in a gas, explaining why certain reactions occur more readily than others. This field is essential in the design of more efficient engines, the development of new materials, and the study of complex biological systems. And that's a wrap. Statistics isn't just about numbers, it's a versatile tool that helps us understand and navigate various fields. From predicting economic trends to exploring the cosmos, the applications are endless. If you enjoyed this video, make sure to like, subscribe, and hit the bell icon for more insights into the world of science and data. See you in the next video. Thanks for watching. Leave a comment below about which field you found the most interesting, and let us know what other topics you'd like us to explore.